I've heard enough feedback on that one. I think it's worth considering also. There's certainly planning software. There's Deep Sky Planner, Sky Tools. There's just tons of these. And these are programs that, you know, given your location and sky conditions, can make some pretty good suggestions. I know Roland uses, is it Sky Tools or is it, which one is it?
Sky Tools, mostly, yeah.
So, and of course, Deep Sky Planner is a good one. So there's one built into Nina that I've played with. It's kind of a toy compared to those two. I didn't put it on here. There's some really good books about finding targets, but there's so many internet references and people in the club. I think you could probably get started without having to go buy a book. What I've done is, in the past, I would read internet forums and just make links to any images I liked and then put those in a spreadsheet. So I've got like 15 years of ideas that to work on. And nowadays, I just bookmark any images on Strabane I like. And then I can just scan through those. And I have more targets than I could ever image. So that's another way I do it. Now for planning the observation, so you figured out you want to image a target, you need to figure out your field of view for your camera and telescope. And then it's really nice to go and actually frame the object so it fits in that field of view nicely. If you, for example, typed in M66 in your handset and slew to it, you'd get M66 in the center, but I think it's M65, which is real nearby. It might be just cut off on the side of your frame. And if you sat there, and that's two of the three galaxies in the Leo trio, if you take the time to frame it, you could get both of them in there and get a better image. So I always try to do some framing beforehand. I see Richard. Yeah, I'll make this presentation online somewhere. I figured I'd go through it and make any corrections and then put it up. But so Aladdin is a program I've used quite a bit, and I gave a talk on, and I have a link here to a YouTube video I did about how to use it. It's free. It has a sky atlas built into it, so it has images of the entire sky, and you can slew it around kind of like Google Maps to wherever you want and overlay a field of view. It's really handy. SGP has a similar type of functionality as well as Nina. I think SGP, you can give it the URL of a Strabane image and it'll center it for you. So that's kind of handy. Nina downloads an image and you can put your field of view over it, click create sequence, and then hit image. You know, we'll just slew there, plate solve, and start imaging whatever you did. So the software has gotten quite sophisticated. You can certainly just use a handset on a telescope and do these things as well. I'm not saying that doesn't work, but I think most of us have moved on to cameras that require a laptop. So the software kind of just comes with the deal. As for pointing, I think what I used to do is always just slew to a star nearby and sync the telescope after I'd centered it. And then if you slew to your actual target, you are usually pretty close. But these days, almost everything supports plate solving. And is everyone familiar with plate solving? It's where you, the computer takes an image and then it uses a star database and it actually figures out where you're pointing in the sky. So if you're not on your target, it'll actually make corrections until you're pointing where you want it to. And I know SGP and Nina, Voyager, it's quite easy to get it working. It used to be a real bear to get a plate solver working with software, but now it's quite commonplace. So that's kind of, we'll stop there. That's kind of just what an overview of targeting and finding targets. I was interested if there are any particular questions about those topics.
So Chris has a question. Chris, go ahead.
Yeah, so can you hear me?
Yes.
Okay, looks like him. Yeah. All right. So the thing I was wondering about is you just touched on plate solving. So it basically tells you how to adjust your field of view to make sure you're centered on what you desire to image. Does it I still have barely used plate solving, but does it tell you if you need to swivel your camera in a different direction to get the best orientation of what you're trying to attempt?
Yeah, so when you plate solve, you get a position, which is the center, and it gives you, they call it different things. It's basically your rotation on the sky, and different software seems to do it differently. Usually it's degrees clockwise through east from north, I think, but all I know is with my setup, it's 0 degrees. That means the x-axis is along RA, and depth goes along the y-axis, and 90 degrees is when you rotate it. So I usually only use 90 or 0 just to make it easy. And yeah, you just do a plate solve and it'll come back and say you're at 78 degrees. So you nudge it, plate solve, until you get the rotation you want. So it's quite handy for that.
Yeah, I see.
See, Arjun's also got a question.
Hey, do you guys hear me?
Yes.
Okay, yeah. No, so so one thing on plate solving that I'm doing with that ASI error, but I think the other tools have it as well, is that you go to a certain object, it plate solves it, it kind of sees if you're actually pointed at that thing, and then it kind of does micro alignments to kind of precisely center the object, right? So that's this kind of go to in combination with plate solving is super powerful. So that was just a thing I want to mention. But regarding trying to figure out what's visible, right? I'm feeling right now it's a frustrating season because everything is like small galaxies instead of cool narrowband nebulae and stuff like that. But it's kind of hard to figure out like what's the optimal time to image certain objects, right? Like, so certain things might be visible now, but maybe it's just better time spent like in say May to visit that object versus doing it in March because it's just too low on the horizon, etc. But I haven't, I'm still a beginner. I haven't figured out how to rationalize like, okay, well, this object is now low in the sky, so it means it goes higher in like 2 months. So what's the optimal time to actually start going after that object? Is it what's the right season for certain objects, right? So I don't know if there's a trick to kind of help wrap my brain around that.
Yeah, so I don't know if y'all see Nina up on the screen now.
We do.
Yeah, so yeah, this Sky Atlas. Now Nina, we'll talk about it at another point, but it's under really active development. So if you want the cool stuff, I don't know how y'all familiar y'all with nightly builds for software, but basically they build it every night. And you're kind of getting what's on the top of the development stack, which hopefully works, but if someone's integrating a new feature, things might break. It's kind of like doing Windows updates or something. But so this, in theory, is an object browser where you could go in here and you could say, I want to see all the galaxies that are up, and do a search. And if you do that, then it goes through and now, right now, like it brought up the LMC, which is not particularly helpful, right? So, but you can see over here on the side, it shows a chart. This along here on the bottom, I don't know if you can see my cursor, but it's time. So midnight's at 00. And then it shows altitude versus time, and then it shows where it transits. It's going to be in the north. It transits at 58 degrees. So that's, let's look at M81 right here. So M81 transits around 9 o'clock. It's not even dark yet. That's what this gray area is. So that's probably not a great target. But here's M106, and that's a much better target, right? Because you could get started early. It's going to transit, and then you could image it. So this is just built into Nina, and if with this you could type something in, like M66, and it shows it's altitude versus time. Now, I know Sky Tools and the other planning tools would do this sort of functionality also. But in this case, I'm going to send that to their framing assistant, which is going to download a sky image, and it has M66 centered. And then over here, can y'all see my mouse or not?
Yes.
Okay. So this is roughly the ASI 1600 XY and pixel size and the 800 millimeters I just picked. And that's what this white box is. That's the field of view. So you can move this guy around and you can rotate it, get it where you want it. Coordinates are up here. And then I'm going to say replace as sequence. And in theory, now we're on the sequence screen. I know you probably haven't seen Nina before, but this is a screen where you would create, I want this many L frames, R frames, whatever. So here, you know, I could say I want 25, 60 seconds each, you know. I don't have anything defined on this computer, so it doesn't know anything, but you would basically set up your filter and all that. But the important thing is it populated this area with the rotation and the coordinates that you selected. And then if you hit, you know, start sequence, they would salute those coordinates. Now, if you had a rotator, it would actually rotate your camera, but most of us don't. So you'd have to take care of that rotation before, but it's kind of slick. And SGP has a very similar tool to this. But as I was saying before, you know, if you had a small field of view, like with my C8, I'm at 1400, so it's fairly tight. You know, if I do this right, I can get both of them. But if I just slew to the coordinates for M66, that's what I'd get a picture of. So that's why I would always recommend trying to frame things, because there's a nice framing, right? And, you know, if you're really diligent, you could do that and then plan another one up here and do a mosaic. And in theory, this does mosaics. Oh, there you go. Oh, maybe I just want one. Nope. I want one. I haven't ever used this, but you know, there you go, bang. Now I don't know if you put those in the sequence, if it creates, yeah. So it created panel 1 and panel 2. So those are the two panels. If you have enough dark time and enough clear skies, it'll just sit there and crank through all these panels automatically. And when you wake up, you'll have all this data. So really recommended to use these kind of tools now.
We got, Andy's got a question.
Yeah.
Hey, Michael, can you rotate that field of view using, like, grabbing a corner of the square like you can in Aladdin?
No, yeah, that's one thing about Nina. I've noticed some of the UI is a little not as interactive as you would have expected. Like, I'll bring it back up. You can't, as far as I can tell, you can't like drag the, there's no drag for the background, right?
Okay.
You know, you have to use this scroll bars. I could be wrong. I've only used this for about the amount of time I showed it to you. So, because I use Aladdin to plan all this, but you know, this works just as well. You know, if you wanted to go to a different target, you know, like M81, you just would hit that. It would find it, load it in the framing assistant. Now it's loading the image. That's what this guy's telling us. I don't know where it's pulling it from. It says NASA Sky Survey, but I don't know if that's a fast server or not. You would have to have the internet to use this, by the way, right? If you were out at the field, you couldn't, well, you could use your cell phone, I guess, if you're somewhere like Big Woods. But so again, here's a target where, you know, if you were really clever, you might be able to get them both in at my field, you know, my field of view. But, you know, most people are probably closer to 1200 with their C8. And, you know, you can get stuff. So it's really handy. You know, I used, you know, when I used the image before all this was around, I remember I would find the brightest star in the frame and figure out what XY coordinates they were at. So the next night I would move the scope around till that star was at those XY coordinates. And then when you're meridian flipped, you'd have to do it again, except everything's flipped 180 degrees. Plate solving is just a godsend. It's just so easy. And when it meridian flips, it'll automatically use plate solving to go back where you're pointing. Because I know with my setup, it's usually off a few arc minutes when I do a flip.
Mike, I got one more question.
Yeah.
I've been using PlateSolve 2 for plate solving. Is that generally the one to go to when you start out, or is that considered the best one?
I think there's one called ASTAP, that I think most people are gravitating towards. It seems a little more robust, and it can actually do blind solving.
Okay.
Blind solving is where you're way off. Usually a plate solver wants you to be, let's say, within 5 to 10 degrees worst. And it will take a while, but it just basically searches around the sky until it matches up the patterns. Blind solver, you don't even have to know where the hell you're pointing, and it'll eventually figure it out. On my laptop, PlateSolve 2 could take 5 to 8 seconds, and ASTAP, this is a local solve, not a blind solve. It's usually a second or less. It's amazingly fast.
Wow.
Really clever guy working on it and supporting it. Whereas PlateSolve 2 is kind of, the company made it available for free, but there's not a lot of documentation or support for it. So my recommendation, if it's working, to stick with it. But ASTAP actually has a way, if you rename it to PlateSolve 2, it accepts the same command arguments as PlateSolve 2. So because software wasn't supporting it initially, he made this sort of workaround. So you would just point SGP at the ASTAP program called PlateSolve 2, and it would work. So, but I think everything, well, Voyager probably doesn't support it yet because that guy's, but otherwise, does it, Roland? Does it support it yet?
Yeah, it works.
Oh, good. Yeah, I use ASTAP. It's easy. You just grab a binary and then you grab this huge star catalog and install it, and it just works.
Arjun has a follow-up question.
Yeah.
Let me unmute you here.
Yeah. Hey. So yeah, that's super helpful, all that stuff. So you know, to kind of dig into my other question a bit more. So you see this transit graph, right? And it's like 56 degrees, right, on your screen. So
yeah,
you know, how can I estimate, like, is this the best it's gonna get? Or in 2 months will it be like 80, so it's like way higher up in the sky and it's a better time to kind of hit that target? Or is it like the highest it will ever get because it's just so low, like a southern kind of object or stuff like that, right? How do you
right?
Yeah.
The easy way for me to think about that is every month the sky, let's say a month from now, then whatever's overhead is going to be 2 hours different than it is tonight, because we go around the sun once in 12 months, so everything shifts. So, you know, in a month, it's instead of at 2100, it would be at 56. It would be at 1900. It would be at 56. And a month ago, you know, at 11 o'clock, it was at 56. So this curve just slides around this graph through the year. Whereas, you know, in 6 months, it'll only be up during the daytime, right? So I don't know if that helps. My advice is if something's transiting, I don't know, are you usually imaging just a few hours at the beginning of the night, or are you letting it run all night?
He's muted.
Did I lose you guys?
No.
Yeah. You know, it varies, right? My scope is really fast and doesn't have a filter wheel that can fit in the front. So, you know, I'm kind of limited at some point, like how many hours I can do. But
Michael, yeah, I just threw into the chat that SkyTools has what they call a year bar, which shows when it exactly answers Arjun's question.
Okay, cool.
But that's an expensive way to answer the question. It's like a $150 program. I don't know if there's a equivalent to a year bar, which shows, you know, it just basically shows a graph just like the night graph that shows when it's highest at the night, but it shows when it's best over the course of the year, or it shows every month. I don't know if there's a free version of that out there anywhere.
I don't know. I mean, you can go in Carte du Ciel, and at the top, I don't think I have it installed on this computer. It has, you can jump through time, you know, days, months, weeks, whatever. So you could just set it for a week and just jump a week ahead and see how it moves in the sky. But generally, you know, you just need to look at what the sidereal time is at midnight for the first of every month. I'm sure you can find that online somewhere, or just figure it out. And that'll pretty much tell you what RA is transiting at midnight at the beginning of the month. And then from that, it's pretty easy to go through and just throw out things that are, well, like I say, like M81, I would probably not mess with, just because, I mean, it wouldn't be bad. You could image it for a few hours, right? I usually image down to about 40 degrees or something. So, oh, by the way, if you click on this, it tells you, right? So you could get 4.5 hours. That's not too bad, right? But you know, something later in the night, like NGC 4665, you know, it transits closer to midnight. I don't know if you guys have ever imaged that. It's a beautiful, big old edge-on galaxy.
Barton had a question as well, which is, you know, it's not going to get higher than 56 any time of year, which is.
Oh, no, yeah, obviously, yeah. Yeah, if you can observe it transiting, that's as high as it ever gets. So, yeah, you know, it's certainly worth considering some of the software, but I would encourage you, if you just spend a couple months just going over things and learning how the sky works and where things are, I think you'll kind of have a good feel for all that. All right, any other questions?
Looks good.
Yeah. All right, we can bounce. I'm sure I'm blowing through time, so I'll try to be quick, but
Not bad.
I'd like to have I'm interested. I don't want to spend a lot of time talking, but if we're doing questions, I don't mind spending time on it at all, because I think that's helpful.
I think it's going great.
All right, so another question that's always come up is about exposure times. You know, how long should you be exposing for? And then how much data do I need? And the second one's easy to answer, which is, for most of us, we'll never get enough data. You know, we're dealing with light pollution or other things. So you just get as much as you can until you're sick of imaging it. And then hopefully you got enough to make a nice image. You know, I usually go for 30 to 50 hours now, just because I got nothing else to do except set the scope up and let it run all night. So it's easy to achieve. But when I had to sit with the scope, you know, I was typically getting 8 to 10 hours per target. So you get what you can get. But for exposure time, the idea here, excuse me, is there's noise from the camera that's present in every image. That's called read noise. And then there's noise that we get from collecting data, which is counting photons. That's called a Poisson noise. But the important thing is, you know, the more photons we collect, the noise level will increase, but fortunately the number of photons we're collecting increases faster. So overall, the signal to noise ratio improves. If we took a really short exposure, so we only like registered 1 photon, and then our camera had a read noise of several electrons, you would be hurting when you tried to stack that, because what you're stacking there is basically read noise and not stacking interesting data. And so, you know, some people, like when you're doing EAA, you're ending up sometimes, depending on where you are, not taking as long exposure as ideal. And for brighter targets, that's fine. But for some of these faint targets, it's called stacking efficiency, which is the signal to noise level you would reach after a certain exposure time with no read noise compared to when you have read noise. And if you expose for the optimal exposure time, then you will come pretty close to getting the theoretical benefit of stacking. So what this will give us is at a time which we just want to reach that level. We don't have to go past it. We've already hit the optimal level. You can go past it, and I'll talk about that some in a minute. But basically, the things we need to consider to figure out this exposure time are your read noise from your camera, which is given with the specifications, or it's fairly easy to measure yourself. I won't go over it here, but if someone wants to do this experiment, I'd be happy to help you. You need to know your bias level, because you need to know how many counts are coming out of your camera when there's no light hitting it at all. And then you just need to know how bright your sky is. The brighter your sky, the shorter your optimal exposure time, which sounds like a good thing, but that's not a good thing. That just means you can hit that point faster because the light pollution is contributing to the photons you're collecting.
Got a question from Michael Mantini. We can take a quick interrupt here.
Yep, of course.
Hey, Michael, where I'm challenged is, and I would think this would affect exposure times, is setting the gain properly on the camera. Do you aim towards staying at unity most of the time?
Yeah, I'll address that in a minute. That's a good question. And yeah, with these newer cameras, we have another slider we have to think about. So, but to answer it, I typically use a lower gain for broadband, and I use a higher gain for narrowband. And I'll touch that in a minute. And then if you still have a question, just hit me back, okay?
Okay, thanks.
Yeah, so I'm not going to make this like a mathematical derivation or anything, but I just want to give you a few things that you may see or have seen. Basically, the idea is you do a noise budget, and in each frame, a certain amount of noise comes from counting photons, and then some of it comes from the camera. And you set up a relationship so that you get the majority of your noise budget is from counting photons, which is what we want. And the way those are expressed are things like 3 times the read noise squared, 5 times the read noise squared, or 20 times read noise. And if you search cloudy nights for, you know, ASI 1600, optimal gain or something, you'll see tons of threads about this stuff. And I'll talk a little bit about how you get that number in a second. But the point is, if you choose your exposure time, so the background of your image, which in SGP it reports as a median, you know, other softwares will have an average or something. You just need your background level to reach that number of counts. If you hit that, then you're going to get good results stacking. If you expose longer, you don't necessarily benefit in a statistical way, but you do risk overexposing the brighter stars, potentially part of the target. You know, you have a greater chance of guiding going AWOL. You know, if your optimal exposure is like 60 seconds and you decide to take 10-minute exposures, I don't know that you would see a big difference in the result, but obviously having to throw away a 1-minute frame because someone turned their lights on and left big woods or something is a hell of a lot better than a 10-minute frame, or, you know, you bump the scope. You're only losing 1 minute, not 10 minutes. So it's good to know what that number is. Now, on the other side, if for some of us with light pollution, it may be something like 10 seconds. And obviously, we're not going to shoot a bunch of 10-second exposures because stacking that would be insane. So you have to use your judgment of where to, as long as you're not overexposing anything important, you can certainly go longer. Now, if you expose shorter than that, then basically you'll get an image, but when you stack it, let's say you took 61-minute exposures or 3,600 1-second exposures. They're both 1 hour, but you're probably not going to get as good signal to noise from that one with 1-second exposures because you probably, unless you're in New York City, you're probably not hitting the optimal exposure time. And the read noise is slowly eroding your overall read signal to noise ratio. Are there any questions about these ideas? I'm happy to go over it again. As I said, I'm trying not to make this mathematical. This is more conceptual. But so with the ASI 1600, now here's the math. And this is, I based it on this link down here. And I'll post this later. But the idea is, you know, you put in all these numbers and you'll get a value. So down here at the bottom, let's just focus on that. Gain equals 139. On a 1600, that's unity gain. That means every readout number you get when you read out the camera corresponded to 1 electron being detected. The read noise is 1.6 electrons. You throw all those numbers in this equation up here, you get around 1,000. So if I were going to set up my exposure time, I'd take, let's say, a 30-second exposure, and let's say I got 800 counts. So I'd bump that up to a minute, and let's say I got 1,200 counts. Well, that's over the minimum required, and it's not terribly over. And assuming I'm not burning out any stars that I care about, I'd probably just set it up to go with 1-minute exposures and not think about it again. If you change the gain or the offset, then this number will change. And I thought, here we go. So here's some common values. Gain 76 is what I use, like for my recent galaxy image. It's a lower gain, and I had tons of signal, and so I wasn't worried about the read noise as much because it was easy to swamp. And this said 960. I think I was getting around 1,400 in every frame because 60 seconds was as short as I wanted to go. I had 671 of those exposures as was. I was not going to go any shorter. It took 3 hours to stack, so I didn't want to make it longer. 139 is also common. And then for narrowband, I use 200 because you can see the read noise drops a bit. And a lot of the targets, when you're shooting O3 and sulfur 2, you may not be able to swamp the read noise because you're filtering so much of the sky out. And your target may be really faint in those filters that you may struggle to get to that minimum exposure time. So by increasing the gain, you lower the read noise. And if you remember our equation back here, it's always something times the read noise. So if we can lower the read noise, we reduce the amount of light we need to collect per frame to get good statistical results stacking. So that's why you'll see people go to a higher gain for narrowband. But the sacrifice there is you compress your dynamic range. The well depth is lower. So things like stars are going to saturate much faster. So if you're shooting color, RGB, LRGB, using a lower gain allows you to capture more color in the stars. And but with narrowband, star color is kind of a weird thing anyway with narrowband. Some people replace it with RGB stars anyway. So if you're just caring about a really faint nebula, you pump up that gain value.
Andy's got a question.
Yep. Hey, Andy.
Hey, Mike. Oh,
You're good.
Okay, so you mentioned with narrowband, you might not be able to swamp the read noise, and if you have a lower exposure, you might be not swamping it just by accident. If you did a whole imaging session like that, what would be the end result in your final picture? What would how would that affect the final result? What would you be looking for to realize you weren't doing that?
Well, it's hard because you really, to tell what you're doing, you need to be able to compare it to data which wasn't contaminated by read noise. But essentially, you would just find, if you used a suboptimal exposure time and took an hour of data and someone else did, and you compared your images, assuming everything else was the same scope, same everything, then you would just find your image would be noisier. Now, it's not going to be compromised, most likely, but you just won't get as much benefit of total exposure time using exposures that are too short.
Would it be noisier across the whole frame or just the dim areas, for example?
Overall.
Okay.
Because the read noise affects every pixel. So yeah, it's hard to, I've tried to come up with a good example using something like a ruler that had reading noise. And if you tried to measure a mile with a 1 millimeter ruler versus a yardstick, your accumulated errors and things, but I haven't been able to work that one out yet. But essentially, it came about because with CCD cameras that potentially had 10 or more electron read noise with lower sensitivity cameras, I'm talking 10 years ago, you couldn't simply not get a low enough exposure. It would be in the hours potentially. So that's why people started to do color bin 2x2 and all that stuff. So now that we have these low read noise cameras, it's really interesting to start figuring this out. You know, it's kind of nice because with a common beginner camera back then would have been like a KF 8300 camera, 10 electron read noise, same size sensors as 1600, set you back about 3K at the time. You would need, for narrowband, 30 plus minutes to hit the optimal exposure time. Very few people could track 30 minutes without expensive equipment. You know, with the 1600, a 300-second exposure in narrowband is usually pretty close. And now we can start to use a lot more acceptable mounts to do this stuff. So I think generally, you know, you don't have to obsess over this stuff. I would do what you can track. If you can only track for 2 minutes, then I would use 2-minute exposures. I wouldn't try to do longer ones and throw frames away. That'll hurt you more than just not hitting the optimal exposure time.
Okay, cool. Thanks.
Got a question from Chris?
Yeah.
Let's see. Chris, you moved in my list. Just a second there. All right.
Well, this was a while back, but it's basically a question of your sky quality as far as light pollution. Because I mean, we've been seeing, you know, on Yahoo some of the galaxy images that you've been churning out. So I'm just curious, what kind of sky quality is over at your place? Are you in Fuquay or Cary? I can't remember.
I'm kind of between Cary and Apex, so not in the middle of it, but with all the construction now. And there's a little golf course nearby that has this nighttime play, so they're on for a while. But I think I measured it around 18.7 SQM. Yeah, what does that mean? Well, 10 years ago on a cold night in the winter, you could barely see the Milky Way. I can't do that anymore. So I'd say it's somewhere between 4.5-ish visual.
Mm-hmm.
So it's probably 5 times brighter than Bigwoods.
Oh, wow.
And probably, I don't know, 10 to 15 times brighter than Staunton River. So, yeah, it's just a matter of just really just sitting on stuff, and then a lot of work with DBE cleaning up the background.
Mm-hmm.
But we have software now that we can get rid of the gradients. You know, obviously that doesn't remove the noise from the light pollution. But I think, you know, I kind of gave up on doing LRGB from home, but I guess I've gotten bored, so I started trying again. If you can get hours of data, you can do stuff on some nice images. Especially if you choose ones that are compact, you know, not something like M101 that's spread out all over creation, but, you know, kind of like, you know, these guys I was showing earlier, M66, M65, they're real tight spirals. So there's a lot of light in a small area. You can do a pretty good job on those.
Okay. So you're more about, as far as what you're just saying right now, is it's easier to go with objects that, not necessarily the size, but just how much the object glows just based on the proximity of the composition of it, right?
Yeah.
Okay.
Yeah,
So,
definitely.
So, you were saying with M101, you know, yeah, I could see how that's faint. I mean, I tried it a few times just to see how much exposure it would require. But I mean, when you get down to it, I mean, if you're okay with doing it at a shorter focal length, M101 gets to a point that it's a little more doable. Is that correct?
Yeah, I mean, that one would always be tricky. It's so spread out. I've done it from dark sites, and it's a bit of a challenge.
Okay.
You know, but like these edge-ons, like this one I'm trying to bring up, I typed in the wrong thing earlier.
What about 4565 edge?
4565, not 4665. It's easy to get them confused, I guess. But I mean, this is a nice little compact guy, but this faint part out here would be a bit of a challenge, you know. But when this one loads, I'll show you. It's an edge-on, so all that light's kind of, you know, I mean, there's things like M81 and M82 that are pretty bright, but you know, here you got this edge-on galaxy. Let me get this stupid thing out of the way. This is the edge on is really bright. You know, that you're not trying to eke out any little faint arms or anything. You could probably do a good job on that. And even this little companion over here would probably be all right. But my old nemesis was, you know, this time of year, or maybe a month ago, your galaxies are too far gone. They're in the trees. Leo's not quite up yet, so there's NGC 2903. I tried to image that little sucker a lot when I was starting out around 2003, and it's got a really bright core, but the arms are just faint, and it was not something I would choose now probably. Now the one I did do, NGC 4725, has this really long faint arm, but I got 25 hours of data on it, so that's not something you're going to do in one night.
No,
For reference, that's probably about 2 nights of data at Bigwoods. So you can see this guy, it's tight here, but these little arms, that would be tough, right? So I wouldn't pick this kind of galaxy.
Got a question from Quincy when Chris is wrapped
Yeah.
up.
Yeah, you can mute me.
Okay. Quincy, are you with us, sir?
You know, I don't have one. I'm just really looking at the realm of possibility if I ever invest. But what is a good beginner imaging camera?
Oh, equipment? Is that your question?
Yes.
If you can hang around, can we slide that to the end? And then we can kind of, I got one more thing I want to go through, but I'll be happy to talk about that topic if that's all right.
Sure.
Okay. Yeah, we can sort of open it up at the end. I was just going to talk about guiding a little. If there's no more questions about, what am I talking about? I've forgotten.
Yeah, exposure length.
About
I think going to
exposure
guiding would
length.
be good because
Yeah.
we got 15 minutes until, more or less, until 2.
Yeah. But if there's another question, I'll be happy to address that. Otherwise, I'll jump back in. All right. I'll keep rolling.
Keep going.
All right, so auto guiding. I'm sure most of you guys are guiding, but again, I'm just going to throw out a few ideas and then we'll hopefully get some good questions. Generally, you either have a separate scope and camera or you use what's called an off-axis guider, which actually uses the main scope to collect the light, and then you have a separate camera attached to it. It has a little pick-off. The software just watches a star, and if it shifts, it's kind of like laser targeting. It'll just move the scope to put that back where it's supposed to be and keep going. So it deals with all kinds of polar alignment errors or periodic error in your mount where it periodically drifts an RA back and forth. If you use a separate guide scope, it has to be mounted rigidly. Otherwise, as you move your scope across the sky and the vector of gravity is pulling on it in different directions, it's going to point in a slightly different direction than the main imaging scope, and you'll get what's called differential flexure. So you'll look at PHD2 and have perfect guiding, and then all your stars are stretched out for some reason. So, it's good. Nowadays, it's good to have a smaller guide scope instead of a god-awful huge one like we used to have to use. That makes it easier to mount. And finally, something related to auto guiding is something called dithering. And that's where you occasionally just slightly shift the point in space you want to guide on. And what that'll do is it shifts all your light frames around so that when they stack, the pixels are all kind of mixed up when you're in the background. And it helps get rid of hot pixels, cold pixels, all kinds of pattern noise. It really improves the image quality. So, it's really important. You can do it without guiding, but if you're guiding, you need to have it set up so that it'll also dither.
Michael Mantini has a quick question.
Yeah. Yeah, Mike.
Could you please explain, Michael, the importance of doing a really good polar alignment and how that directly affects your ability to guide? Just real quick. That's something I struggle with. Sometimes I found that, if I rush too quickly, through the polar.
Yeah, typically, so if you're, one method of polar alignment is called drift alignment, and you're watching a star and tracking on it. And in theory, it doesn't drift. But by how fast it drifts, it tells you how far you're mispolar aligned. So likewise, when you're guiding, if you're not polar aligned well, usually you'll see it in RA and deck. The star is going to want to just shoot off off the zero axis on its own, because you're just pointing the axis of the mount in the wrong place. So instead of following the right track across the sky, you're following the wrong one, which makes the mount and this guide software have to work really hard. In addition to just keeping up with the errors due to the mount, like periodic error, now it's trying to pull the polar alignment error out. I never really obsessed over polar alignment. Usually within a few arc minutes has been good enough for me. I know some people like it when they get it down to 3 arc seconds and pull a line back or something, which I think is kind of meaningless. I'm not even sure I'm not sure it even properly handles refractive adjustments and things. So I think anything less than arc minute is probably the same. Now, where it can hurt you is even if you guided properly with, let's say, 10 arc minute of polar misalignment, you'll start to get something called field rotation, which means the center of your frame will be in the right place. But as you move across the sky, you'll see the star, and you stacked it, you'll see the stars in the corner are starting to rotate around the center, which then when you have to stack it, and you'll end up having to crop your frame because you don't want to have these weird looking arcs out at the edges. So again, if you're getting it to a few arc minutes, unless you're at a really high focal length or you have a huge sensor, I wouldn't worry too much about it.
Okay, thanks.
Yeah, I mean, I used to use my Sirius. I just put Polaris in that little circle in the polar scope, and I was done, and I just would image. So,
well, one last thing I've observed when I was out a few days ago was I was guiding, but yet my deck, I had a nice straight line, but it was well below the RA line, and it was tracking with it, but it wasn't over top of RA. And I've never seen that before. And I thought maybe I try. It's hard for me to do a polar alignment because I have this big tree.
Yeah,
and
I understand.
I've got to try to position my scope so I can see through the branches to see Polaris. But deck, I thought I did okay, but it was weird that I wasn't getting spikes or anything. I was getting a nice straight line on deck, but it was below. This is in PHD2. It was below the RA line, and I'm like, well, what in the heck does this mean?
Do you mean it stayed inside of the envelope of the RA line, or it was always below?
Well, I had RA above it, and then a quarter inch below it or so was the deck line. I normally obviously see them riding on top of each other, and I didn't know I didn't know what that
Are you
meant.
talking about drift alignment or guiding lines?
I guess they're the guiding lines. I was actually collecting data.
Right.
And I wasn't seeing any, though it was only a minute worth of data. I just never seen, it was like an offset. It's like the deck was offset from the RA tracking.
Do you have corrections enabled on your graph?
I don't believe so.
Okay, there's a little checkbox there for corrections, and it'll show you what it's trying to do. It sounds almost like, usually PHD2 will go into this resist switch for deck.
Okay.
Because a lot of deck axes have backlash, and you don't want to just keep trying to guide back and forth over zero, because you'll never run out that backlash. So PHD2 will kind of sit there and watch and see if it can actually detect some drift, either north or south.
Yeah.
And then it'll learn. Then when that gets past we'll talk about in a minute, minimum move criteria, it'll send a correction and then drift back down to minimum move again. Okay. So if you hadn't triggered any of that, it may have not been sending any corrections.
Yeah, I'll look at it. Yeah. The mount behaves a lot better since I converted it from belt to belt from years.
Oh yeah. Yeah.
And behaves, it's like, it almost behaves as well as my, or just as good as my Pro Atlas mount. But I just never seen this before, and I was just
Yeah.
curious. Yeah.
Okay. All right.
Thanks.
Yeah, of course. All right. So I was just going to go through just the two modes. One's where you have a separate guide scope. That's probably a lot of us are using. Generally, it's easier to find a guide star because you're usually using a small scope, short focal length, maybe 1 to 2 degree field of view. So you almost always can find a good star. It doesn't interfere with your back focus because it's a separate telescope. So if you have something like a Newtonian with a really tight back focus requirement, you don't have to figure out how to get an off-axis guider shoved in there. And also, just as an aside, you can just fire a sharp cap, point it at your guide scope, and just polar align. So it's you kind of kill two birds with one stone when you set up a separate guide scope. You don't have to go buy any extra hardware. One of the cons would be, like I said before, differential flexure is always a problem. It's always there. It's just a matter of how long exposure you can take before it becomes a problem. It does add more weight because you're usually sticking something on top of your scope, putting it farther away from the rotation axis. So you need more counterweights, et cetera, et cetera. Makes maybe push the mount to the point where it doesn't like to guide with that much weight. And if you have something like an SCT with the clever way of mounting optics so they can shift around, then you will not want to do this unless you're taking very short exposures. If you have a SCT where you can lock the mirror, then obviously, that's not a problem. But, that's true for even big scopes, big RCs and other scopes, they're just big pieces of equipment, and they do shift a little. So an OAG will see all of those shifts and guide it out. So any questions about using a separate guide scope?
That's good.
So off-axis is where, and if you haven't seen it, essentially it's something you thread in between the camera and the telescope. It usually has a little prism that you try to put out of the light path that's going to your main sensor. It'll pick off that light and send it to another camera, and then you feed that into your guide software. So since it's looking through the same scope as your main camera, it picks up any flexure or tracking of your main telescope. So you won't have any kind of differential flexure or anything. It's definitely the closest you could get to tracking true. Generally it'll weigh less. An OAG might weigh less than a pound, and then the camera, whatever it weighs. So you can reduce the weight of your setup. And because you don't have a separate camera and separate scope and rings and mounting plates, and it does simplify your setup. Where it bites you in the rear is it can be hard, especially a low focal length, to find a guide star. With my C8 at 1400 millimeters, I have to use a very thin, I use a very thin OAG with a small pickoff. Yeah, it might be 10 arc minute field of view that you're trying to put a star in. With something like an ASI 290 Mini, which is 90% QE and just hot as hell, you probably wouldn't have much trouble, especially for a target in the Milky Way, like a nebula. Where you get in trouble is where you're looking out at a galactic plane, like at a galaxy, another galaxy. Bright field stars get a little trickier to find, but you can usually find a way to rotate the whole camera and OAG around to get a star on sensor. And I'll show that in a minute, how you do that. The other thing is it does eat up back focus. So for example, if you have a C8 Edge with their reducer, my understanding is it has a pretty tight back focus, meaning how far you have to put your camera sensor from the reducer. If you get that distance wrong, your stars are going to look not good. So if you don't have a lot of space and you use something like the Celestron has a nice OAG, but I think it eats up like an inch or two of back focus. You may not have that much space in that requirement for your reducer, so you just can't put it in there. I use the Orion thin off-axis guider, and it takes up about 10 millimeters. It's thin enough you can use it in place of a T adapter on an SLR. The disadvantage is, of course, you have a small pickoff, but that's what I've been using, and I really like it. It works well. I use that with my Newtonian that has a real tight requirement. So if you can overcome those two issues, OEG can certainly give you good results. All right, any questions about that?
We're clear. Chris had to go take care of the strawberries.
Yep, yum. All right, so then the other part of this is guiding is the software. These days, PHD2, you may see it referred to as Open PHD2, is pretty much de facto, except for people with remote observatories and a ton of cash. Everyone else is using this. It's free. It's an open source project. If you want to go in there and fix it, you can. I know I've fixed a couple things. It's well supported. They answered questions, and it's getting new features all the time. They're a really active group. Now, what this does is it connects to your mount, and then it connects to the guide camera. It loads images from the guide camera, watches a star, and if it sees that star move, and it can detect fractions of a pixel of a movement, very accurate. It'll tell the mount to move back to where it should be. Now, for that to work, you have to calibrate it. It doesn't know where north and south is, east are on your guide camera. So if it drifts 3 pixels in X, it doesn't necessarily know that meant it drifted east or west. So one time you have to calibrate. I know some software makes you calibrate all the time, but generally you only have to calibrate once unless you rotate your guide camera, and then you're set. I've used the same calibration for a few years now. And that calibration step can be tricky depending on your mount. And I'm not going to get into all the details here, but if you've had problems calibrating, you're not the only person. But there's usually some pretty common solutions. Now, the dithering I spoke about earlier is handled by your imaging software, SGP, Nina, Maxim, Voyager. When you set up a sequence, you tell it, I want to dither the frames. So you don't want to dither while you're collecting data, obviously, because that would smear your stars. So usually it's every few frames, it'll tell PHD2 dither. PHD2 will shift everything. It'll take 10 to 20 seconds to re-lock onto a star. And then it tells your imaging software to continue taking frames. It's all automated. The only detriment is you lose a few seconds. You could have been collecting photons, but the benefit is it really cleans up your images when you stack. So any questions about this part?
Yeah, you have a thought on how many pixels to dither versus your image scale?
Right, so when you dither, you're telling PHD2 basically, it's doing what's called a random dither, meaning it basically moves it a random amount in X and Y. But there is a limit, you don't want it to shift it by 3 degrees or something. So you tell it in guide pixels how far you want to move. So you have to work it back to what you generally want, and this is not exact and I don't have any derivation to prove it, but I try to keep it between 5 to 10 imaging pixels as my dither. What that'll do is if you have little clumps of pixels, a few pixels across here and there, which are maybe a little less sensitive than some other pixels, well, when you stack, if you guide it perfectly, then those dark pixels would reinforce each other when you stack. Versus if you dither, they kind of get blended around with some pixels that maybe were a little brighter and behave a little better. And it kind of mitigates that effect. So, 5 to 10 pixels, but I don't know that there's any detriment to going even further, except you have to wait longer on the guiding to correct, potentially. So that's something I meant to investigate, but, who has enough dark time to try out all these ideas? So I'm about wrapping up here. The final thing is just tweaking your guiding, because you can get through this first step usually, but then you start guiding and you get these lines that are bouncing up and down, and if you're lucky, they kind of behave. But with a lot of middle tier mounts, you need to kind of learn its personality first. I know Andy got a new EQ6R and we set it up, and well, we just hit go, and I think it's worked perfectly since then. That's probably the first time I've ever seen that. But the things you have to do first is PHD2 has something called a guiding assistant. And what that'll do is you start it up, and I think the first thing it does, it just lets the mount track with no guiding on, and it watches the star. And that'll tell it first if you're polar aligned very well or not, but also because, is everyone familiar with the concept of seeing, which is just the stars kind of scintillating and bouncing around because of the atmosphere? So even in best case, you're not going to get a flat guiding graph because the atmosphere is bouncing the star around, and you don't want to try to track that because it's happening many times a second. So it learns about how much bouncing around there is just from the atmosphere. And then it will start playing around with the mount some, and it will come up with some suggestions for different values you need to enter. So I would recommend always running that and just seeing what it tells you. Now, the important values that you got to first consider are the aggressiveness and the minimum move parameters. And there's one for RA and one for DEC. Aggressiveness just tells it how strongly to apply a correction. Let's say it decided you were 1 arcsecond off in the north direction. If you set your aggressiveness to 100%, it would tell the mount to move 1 arcsecond. But generally, when you have any sort of feedback loop, you want a little bit of negative feedback, or you can get oscillations. So usually you set that to something less than 100%. I think it defaults to 70. So it would only move at 0.7 arcseconds and so on. And if you set that too high, then things can start to oscillate, where one guide update, it'll be north, and then it'll shift and go south, and then the next one will go back north, and it just overshoots back and forth. To tame that, you can turn that aggressiveness down. If you set aggressiveness to 0, it's essentially not guiding at all. So you should see all that oscillation go away. Then you just slowly ramp aggressiveness up, maybe 10% at a time, and hopefully you'll start to see it trying to correct without going too out of control. DEC, I usually leave it 100%. DEC doesn't tend to bounce around as much as RA. RA has to contend with periodic error, which is constantly moving it back and forth. The minimum move is controlling how far it lets it drift away from 0 before it applies a correction. And we need that because of seeing. Because, if you were polar aligned really well and you had, let's say you had absolute encoders, so you had no tracking errors, even then you would see the DEC axis bouncing above and below 0 because of the atmosphere is going to move that star around a few times a second. So we don't want to try to track that because our mounts can't make several updates per second, right? So what we want to do is set that minimum move in DEC so we're not trying to react to every time the star twitches in the sky. If you see DEC making lots of corrections, you probably need to increase that minimum move parameter. And that's why I was asking Mike about if he has the corrections enabled, which is a checkbox in the graph in PHD2. It'll show you each update how much it tried to move the scope. And that's really helpful. For example, if it doesn't seem to be guiding and you look and there's no corrections being sent, it's kind of a giveaway. All right, I think I've talked enough. Are there any questions on this stuff?
Yeah, we got Michael, Andy, and Arjun all have questions. So can we start with Michael? You can unmute yourself, Michael. Or not.
Okay, can everyone hear me?
Yep.
Okay, Mike, one of the things, because I don't have the luxury of leaving my stuff outside, I have to set up, break down, set up, break down. And sometimes I do well with the scope balance on the mount, and sometimes I may rush through it and it's not so good. Have you seen, and I've seen this only a few times, at certain points during the evening, the guiding may start to struggle because how the weight has shifted on the mount. Do you have anything that you follow in terms of Any rules?
Right. Yeah. That's very common, especially with mounts that don't have a spring-loaded worm or magnetically loaded, like the Optron mounts. Yeah, you'll find generally the suggestion is to be east heavy, meaning whatever, if you were balancing, that the east side would be slightly heavier than the west side.
Okay.
Meaning if you do a meridian flip, you got to slide your counterweight to shift the weight.
Right.
Or, people with G11s tie a rope around the RA axis and then drop a weight down the east side. So there's always a little weight on the east. But, or they do things with rubber bands and bungees. It's pretty funny for a premium mount. But if you don't do that, then what happens is, you could think, if you think about what's happening in the RA axis, there's a worm feeder gear and then the worm gear. And you're either, if you bias the weight a certain way, then you're pushing against the gear that goes around the RA axis. If you don't, the other side's too heavy, then it's kind of riding on the back of the worm feeder, and that tends to not engage it quite as well. So something like a little bit of wind will actually, make it lift up off of the worm feeder. Whereas if you're east heavy, you're always pushing into that gear, so you're engaging it a little more actively. So always set it a little. Now, how east heavy? I don't know. That's something you got to play with. I would not, I wouldn't want it to be 10 pounds overweight on one side, but the way you can kind of tell this is if you do a slew at an intermediate speed west. If you ever play with your scope and you slew it west with a hand controller and then you try to slew it back east, and it's actually like taking out some backlash before it does that move back, that's probably means you don't have it east heavy properly. If you have it east heavy and you go east and west and east and west, it will immediately respond.
Okay.
Generally people set the camera heavy on the deck axis because the camera's closest to the ground, right? And so that tends to make it engage the deck because there's always a little gravity pushing the telescope into the deck gear. But yeah, again, that's sort of stuff you got to play with. But some configurations you may get if you track too far west, and depending on what's on top of your scope, your balance can shift again. So
right. See, I'm challenged with my Atlas mount because I'm with my Edge 11. I'm right at I think I'm actually over the payload, max payload. So it's well,
yeah, that will certainly. But for example, if you had a Hyperstar and you had a little bit of weight there on the end, I don't think it's a lot of weight, but in that case, you could see if you started out imaging straight up with the telescope on the east side, and then you're going to track across the sky, watching it till it's set in the west. Well, initially the camera is going to be on the east side, but as you track across, there's going to be some point where the camera and the front of the scope with the corrector plate go over the RA axis, right? And you can get some weird things where your weight things will shift there, but generally east heavy, tail heavy.
Okay.
Good, it works pretty well. I know with my Sirius I have to do that.
Okay, thank you.
Yep.
Andy?
Can you hear me?
Yep.
Okay, I just had a quick question about dithering. Do you have any recommendations on how often to dither, or how many frames you take before dithering?
Yeah, so the idea with dithering is you're taking advantage of the pixel rejection you're going to do when stacking. For example, let's say your darks didn't take out all the hot pixels. If you dither in enough positions, then when you do the pixel rejection, it's going to see a hot pixel in a different place on every registered frame. And in only one frame, for example, it would reject those hot pixels, and that's the benefit. So PixInsight, those pixel rejection routines generally say you need at least 8 frames. Because what it's doing is it's trying to get an idea of what the value of that pixel should be, so it can detect outliers. So if you only have 2 or 3 frames, it's really difficult to know which one's an outlier. So the more frames you get, the better. I generally try to get at least 10 dither positions. So what does that mean? Let's say you're imaging 2 hours, you're taking 1 minute exposures, that'd be 120 frames. If you dithered, let's say every 10 to 12 frames, that would give you around 10 to 12 dither positions during that run. That then when you feed that into pixel rejection, you're going to be able to, get a good sampling. That's another thing that can come into choosing your exposure time, because if you're going to image for 2 hours and you are taking 20-minute exposures, that's only 6 exposures. That's not going to read, that's hardly enough for the pixel rejection to kick in from dithering. So does that make sense?
Yep. So the
Yeah,
fixed
so
insight
I
algorithm.
would try to get at least 8 dither positions. Now that could be over multiple nights.
Okay. Okay. Yep, that makes sense. Thanks.
All right, Arden.
Yeah, there you go. So I've noticed, because I was playing around with my OAG on this Celestron as well, that the star shapes are really painful, right? And I've read some comments about it as well. They call it like seagull star shapes, and like very really elongated, or out of focus stuff. It doesn't seem to affect guiding sometimes that much, but it's just that almost every guide scope so far, guide solution, I've had star shape problems. You buy a cheapo duplet 60 mil guide scope out of eBay, and it's just nothing is pinpoint. So that's kind of rough. So I don't know if you have any kind of observations about that.
Yeah, certainly. An OAG is pulling off stars way off the main axis, so way outside of the flat field, the corrected field for most scopes. So yeah, it's common to see that. I mean, PHD2 seems to have a good enough centroid and good enough algorithm to find the center of that collection of light, that as long as that shape doesn't change, it's consistent enough, it'll work. I mean, mine aren't too bad. Now, for my guide scope, I have an old 50mm finder that I just jury-rigged to mount for a camera on. And with that, they're actually quite good for that. But with my OAG on the C8, they are, yeah, they're a little odd. But, if you have a bright enough star, it'll probably centroid it.
Yeah.
Yeah.
Okay.
So yeah, it is a little distressing, but
yeah,
generally. Now, the thing I didn't talk about, but is important, is what focal length do you need for a guide scope compared to your main setup? And generally, you want that pixel scale to be, let's say, within a factor of 5. So if you're assuming your guide camera and your imaging camera had the same size pixels, if you're imaging at 1,000 millimeters, then something around 200mm focal length, like a finder scope guider, is going to work well. Most of these guide cameras have tiny pixels now, so that works really well. You may read old books and old articles where they suggest you guide with the same focal length as your imaging. That's for those of us who used to look through an eyepiece and guide the scope by hand. That is not required for a modern sensor with extremely tiny sensitive pixels. So don't do that.
Yeah, no, that's cool. Final question. I've been reading some stuff about like new approaches where you guide on multiple stars at the same time. So that way you can compensate for seeing better. Have you ever seen or investigated some of that stuff?
Yeah, I think Maxim might have that.
It does.
But I don't, but the other form of that, now there's something I didn't talk about, which is called an on-axis guider, where instead of picking off light off the side, you have I think they're called a cold mirror or a hot mirror, can't remember. It's a mirror that reflects the infrared light off the main path. It allows the infrared light to pass through, and you pick off like a diagonal your image visual light to your sensor, and then you have a camera on axis that's guiding in the infrared. It's called an ONAG. They're rather expensive, but really good if you're like running a 17-inch RC scope or something. Most of us probably, I know John bought one, but most of us, it's overkill. So with that guy, I don't know if you know how like an optical mouse works, but it's kind of doing cross correlation of what it's seeing as you move it. And it can figure out the offset just because the scene has shifted. Well, they have a guiding algorithm where they're just looking at the image and detecting when the image shifted. They're not necessarily looking at stars, but mostly stars. But it's a pretty sophisticated technique that's not, it's just looking at the entire frame and how it shifted relative to the previous update. And it's pretty slick. I mean, again, it's kind of overkill for most of us, but they've talked about doing multiple star guiding at PHD2, but I guess everyone's just kind of dubious on, you know, if it's worth the expense of developing it, that you'd benefit from it. But I don't see many people doing it, but it's an interesting idea. I imagine we'll get it at some point.
Okay, cool. Thanks so much.
We have any other questions? If not, oh, there, Quincy, you had your question about what's a good beginner camera and what does one cost these days? I don't know, you want to chat about that a bit, Michael?
Yeah. First of all, you know, I think we're kind of done. So if anyone wants to gracefully leave, no feelings hurt. But I'm happy to stay here as long as people have questions. So, oh, I want to ask you, did you record this, Roland? Or?
I did, yeah.
Okay, good.
Started about 2 minutes in, but
that's fine. I was just sitting here thinking, oops. So beginner cameras, you know, it's kind of, that's depending on what you want to image. I mean, you want to do planetary? Do you want to try to take galaxies and nebula? Do you have an idea?
Planetary primarily. I only have a small beginner camera. It's like a ETX 90 Meade. This little thing, I've just toy around with it. But listening to you guys here, I know all those things are in the realm of possibility at some time in the future. But I'm just really trying to get into the hobby.
Yeah, so, you know, there's if you could find a Canon T2i, it's an older model, but, you know, I don't know that the Canon DSLRs have improved a whole lot in the last decade in overall quality. I think it's more incremental. I think the Nikons are really the ones that have taken off. But the T2i was a nice camera. You could use that to actually take some images of brighter things like M42, M81, you know, brighter galaxies. But it has a video mode, which is a 1-to-1 crop mode. What that means is it will take the very center of that frame and record it for you. And people found, you can do an internet search for T2i Jupiter or something. People were able to get some really nice images just using that DLSR. And it's pretty simple. You just put it on your camera, on your scope, get it focused, start recording to the SD card, put that in your computer, and then, you know, process it. So very simple to get started. And then you'd have a camera you could play with. You could do star trails. You could do, you know, other stuff.
I should clarify a little bit. I have a DSLR. It's a Nikon 5500, but it's heavy on the back end of that little scope. So I was thinking of something, you know, like the little CCD camera.
Well, you could certainly get something like a ASI 120 MC-S, the USB 3 version of that color camera.
Say that again, please.
It's an ASI. I can type it. How about that?
Okay.
How do I do this here? You see the chat?
Yes.
Right. So that's about, what is that, about $150 or is it $199? I haven't bought one. Well, it's a small color camera. It doesn't weigh much more than like pack cigarettes probably. So and it can go into an eyepiece holder. So you could have the eyepiece in there, center your object, take it out and put this guy in there. It's worth investigating. Again, you may find with that aperture and size scope, I just haven't used that focal length with that camera. You'll
No,
get an
that-
image, but you know, it's a question of, it's always hard for me to give advice because it may be something you're happy with now, but if in a month you get tired of that, did you just buy something you don't really have a use for later? In this case, you could put that camera on a larger scope and still get nice images, like a C8 or something. There are more expensive color cameras. You know, the ASI 224 is a really common camera for planetary. I mean, some of the nicest images you'll see were taken with it. And it's also has been in the past a really common EAA, electronic assisted astronomy camera. Probably not in that ETX, but if you put that in like a fast Newtonian, you could take some pretty nice, brighter DSO objects. Again, you know, they're not particularly expensive. In a crutch, either of those could be used as a guide camera. Now, generally, you buy a monochrome camera for guiding, but if you bend either of those cameras 2x2, they're not terrible guide cameras. So if you stay in the hobby long enough, you'll find you'll collect a bunch of stuff. Yeah, you know, I have to think. I don't think I have. Now, before all this ASI stuff, what we used to do is we used to get webcams and somehow fashion a 35 millimeter canister on the end of it and shove it in a 1 1/4 inch adapter. And I have a couple of those webcams. Now, whether you could find drivers for a modern Windows with those, I don't know. But
Yeah.
you know, those, if you look up Microsoft webcam planetary imaging, you might see some people taking $40 webcams and doing stuff with them. If you like to do it yourself, that can be fun to tinker with.
No, those are all good ideas. I like the 2 suggestions you made, and I'll look into those further.
Yeah, I think you could do well with one of those color cameras. Now they're not cooled, so you know if you try to take 2-minute exposures with them, it's not going to work very well. But for shorter exposures like EAA, they do well. All right, any other topics?
I got a question on guiding, which is, have you ever seen or have an opinion on MetaGuide, which I guess it uses video camera and it tries to do more of a full frame guiding?
Yeah. So MetaGuide has been around a long time and is a fine piece of software. Now, what I've used it for is it would do real-time stacking of sub-second frames, and it would attempt to actually, you know, like image the airy disk even when you're seeing sucks, which is really handy if you're trying to collimate an SCP, for example. So it's a slick piece of software, but it will actually just do guiding. I don't know if it does anything particularly. I mean, you could ask Frank on Cloudy Nights. I'm sure he'll talk your ear off, but I think it does some clever things. Now, what you're referring to is it does support, I think it's direct show,
Yeah.
which is what most webcams used to use. I don't know if they still do with modern wind blows, but you could put a webcam in there and it would stack, you know, 1/15 of a second frames from your webcam and try to emulate a long exposure. So you could guide with like a old Philips 740 or something. And I did that for a while. So that's kind of where it originated. But, you know, PHD2 has just some really awesome features. They have something now called PPEC. It's a mode you use for RA where it watches your guide commands to the RA axis over time. And it will try to, using some pretty sophisticated statistics, figure out the PE curve of your mount and anticipate when it needs to make corrections. So after about 2 curve cycles, which is usually like 15 to 20 minutes, you'll notice you might see an improvement in your guiding because it's learned the curve for your mount. Now, it's not the same as loading an actual PE curve with PIM Pro or something, but it's just one of the things that, you know, they've been tinkering with. That's why I said we might get multi-star guiding, because the guys, you can find an open source developer, gets it in their head, they want this, they'll work on it and implement it. So, but yeah, I haven't used MetaGuide for a while because PHD2 just is rock solid for me.
Thanks. We got any other questions? Looks good then. Okay. Thank you, Michael. That was excellent.
Yeah, I would say if anyone wants to quick look at Nina and wants to hang around, I'm willing to go through it for 5 minutes. But otherwise, we'll do that.
I'm going to unmute everybody. You can mute
I
yourself.
would be willing to hang around, Michael, to hear your
Yeah,
your
just a
thoughts.
quick,
Me too.
just quickly go through it. Just talk about how it's the same and different than other stuff. What I'd like
Okay.
to do is during the full moon, when I can't image galaxies, if it's clear one night, I'll just set this up and just start it up, and we'll just image something. I'll show you what I do, but I'll switch back to Nina real quick, and we'll bounce through that.
I like the graphs you showed that look like sky tools that show where the target, when it peaks. That's pretty cool.
So,
And the books and Aladdin.
okay, so here, there's an equipment tab, and you go here and you would pick, now I don't have any, this is a laptop, desktop in my office, there's nothing attached to it, but you would pick, your ASI camera here, for example. You would set up your ASI filter wheel, set up your focuser, pick your telescope, all that's here. But like I said, it's kind of a nice, easy on the eyes UI. I mean, SGP is really powerful, but it is a dense UI. It does a lot of stuff. So when you're starting out, you may maybe be a little overwhelming.
Is this all ASCOM?
I'm sorry?
ASCOM driven, Michael? Is this all
Yeah,
ASCOM
yeah.
driver driven?
It does
Okay.
ASCOM. I drove my Canon with it also, but I think APT is much better for DLSR. I mean, you can tell that guy really optimized at DLSRs. For example, Nina doesn't support mirror up yet. So if you have a problem with your mirror flipping up and giving you a shaky image, it's not good. But so here's the thing. So it does support, I don't even know what the hell synchronized PHD2 is, but this is an external guider. I didn't talk about those because I generally don't recommend them, but this is an actual device you just slap on top of your scope and it handles everything for you. If you're trying to fly to Africa and image with the least amount of equipment, that's probably a good idea. But, so anyway, you would set up all these things with ASCOM. There's this Sky Atlas, so let's say you wanted to image, M106. You just enter that, it'll go out and find M106. Then you just put it in the framing assistant. It'll flip over here, and I guess I loaded it up earlier.
Synchronized PHD2 is multiple guide cameras synchronized so they don't dither while the other one's imaging.
Oh, clever.
Single mount, multiple scopes.
Right, so here given my camera dimensions, which I think over here, it will fill, if you actually connected to a camera, it would fill those in with the right numbers. You have to put in your focal length because that depends on depends on your setup. But then it will bring you over here and then you'll get this field of view. You can move it around and then rotate it, where you want it. And then you would say replace that sequence. So now for some reason, it always replaces what you search for with like some canonical name. So I always have to go back and put it in 106. But, and if you click on that, it'll replace everything. You don't want to do that. So stop. Yeah. So it filled into RA and DEC for me. And you can set a delay. Now, the one thing that Nina doesn't do that SGP pretends to do and Voyager does really well is sort of scheduling. You can't say start this object at 5 o'clock and go till 7 o'clock. It doesn't know that. But you could say to wait, 6,000 seconds and then start imaging if you wanted to just walk away. Also, it really is kind of here. This is basically telling it, if let's say you set up RGB, you want to do all the R, all the G, and all the B, or do you want to do RGB, RGB, RGB? So that's all you can control. You can tell it whether you want it to guide during this exposure sequence. If you turn on slew and center, then that is where it'll slew and then use plate solving to center these coordinates for you. If you put in like an estimated download time, which on Nina is light speed because it uses threads, then it'll try to tell you how long the whole thing's going to take. So let's say we're going to do 60-second exposures. And if I had a filter wheel connected, I could pick the filter here, and the camera connected, I could pick binning. But here it says it's going to start now. It's going to take 1 hour and 1 minute because 60 frames at 1 second readout is 1 minute. So it tells you when it's going to end. And if you hit this big button here, it'll just start to image that sequence. And you can add more, you know, you can add as many as you want. Go through here and change. I don't have another filter to put in here, but you could do LRGB. And that's what I did with that target I was imaging last week. I had I did G, L, B, and R. I can't remember. Anyway, over here, oh, yeah, this stupid thing's in the way. You can tell it whether you want it to dither or not. And then you can tell it, well, let's dither every 6 frames. Right. So I'll get 10 dither positions. So that's all you got to do. And it's pretty much ready to go.
Michael, do you autofocus in between?
Yeah.
your
So
filtering?
where you control that, it's kind of, that's one thing about the UI. It's a little tricky. It's hidden under this little, y'all see what I'm pointing at?
Oh, yeah. Mhm.
It's under there. So you can say focus at the beginning, focus when you change filters, focus every, you know, 30 minutes, focus every 5 exposures. If you have a temperature sensor connected, and I'll show you in a minute, you can say if the temperature changes by 2 degrees, refocus. Or if it's watching, HFR refers to half flux radius. It's how big your stars are. Let's say that changed by 20%, then refocus. So you have a lot of control here over that. I'll jump back to equipment down here under weather. So for example, if you have, it's not here, but if you have like some of these, either it'll look at some web, I guess if you have an API for some website, it'll look at your weather. But for the focuser, I'm not seeing it. Oh, well, one of these screens, I won't waste your time. There's a place where you can, it'll use certain USB temperature sensors, or it'll use the temperature coming from your focuser, because some focusers, controllers support reading the temperature out. And then back here on the sequence, it would use that temperature here. So if it's early in the evening and the temperature drops, you know, 5 degrees in an hour, you know, it'll refocus. I usually just refocus every hour, and that seems to handle most of these things. But, you know.
Cool.
So that's setting up a sequence. You hit go. Now there's a flat wizard. You can either have it do sky flats, or you can have it do, if you have a light box, you can tell it, I want to have a median, I want to have 32,000 counts, and I'll allow between 29 and 36. You can increase that. And then it'll go through, and then you can say the minimum exposure is, you know, 2 seconds, and the maximum is 6, let's say. And then it'll go and take some exposures and then figure out the optimal exposure time, and then it'll take your exposures. If it's doing sky flats, then obviously as the sun comes up or goes down, it'll have to adjust those exposure times on the fly. And I've used this with a light box. It works really well.
Can you have it cycle through all your filters at, you know, like all at once?
Yeah, like I said, I have no astronomy stuff on this, but if
Okay.
you had filters, you would see a list of filters down here.
Oh, gotcha.
And for each filter, you can set criteria.
Cool.
So it's in single mode here. If you have a filter wheel, it'll have something here that says multi-mode. And if you clicked on that, then you can set all this up. So I just put the light box on there and said go, and it just took our LRGB flats. And then I just, you know, walked away, came back. This tab is the kind of the cockpit. Can I get rid of this stupid thing? Yeah, do that. I just see everyone's pictures on top of everything I'm trying to do. So there's a lot going on in this screen, and I won't. Basically, what happens is this area here in the center is where your images appear. This thing at the bottom is showing the guiding graph from PHD2. This shows, it measures every frame you take, kind of like that image history in SGP. So you'll see a graph here of number of stars and your HFR.
That's cool.
Here it'll give you your statistics for the last frame. Over here you can do things like control the camera, the focuser, your rotator. All that's here. Not shown, and I don't remember how to add it. oh yeah, up here. All these stupid little things do something. So you hit plate solving, I don't know if you noticed, it added a little tab here. This, if you click on image, it shows an image. If you click on plate solving, you get this screen, which allows you to just, let's say you just turned on your scope, you slewed somewhere in the sky, you just want to plate solve and sync to get everything all registered. You can use this to do it. There's also it has some sort of polar alignment built in. I don't know how that works. I've never used that. But this is some polar alignment assist. It has, you can also get, there's also a tab when it autofocuses. If you're familiar with like a V curve, where you get this U shape here or something, this shows you, this allows you to manually just autofocus. And then there's this button that says measure focus or backflash, which is kind of slick, which if someone that's interested in, ask me about it in an email or something, but it'll try to estimate the backlash of your focuser for you. So when you're imaging, what you'll generally see is just the image, and then these guys get updated, kind of like the image history in SGP. And then across the bottom on the status bar, it'll tell you like how far into the current exposure you are, how many frames for this sequence it's done, and stuff like that. So pretty simple. This is an image browser. I don't have a way to load an image, but you can have it measure the stars. It has this neat thing where you overlay this Batinoff. Again, I can't show it, but it'll overlay a window on your frame, and if you put that on top of your Batinoff mask, it'll measure how far off of focus you are. But if you're using autofocus, you probably won't need that. Finally, there's just the options. So I think I left most of this set up, but you can switch between kind of a dark theme and a light theme. You can load your latitude, longitude. This is stuff for if you had like a DLSR, you might need to set like the bulb mode. Here you can load your telescope info, focal length, and all that business. Here's some stuff for autofocus, which I'll get into in more detail, especially if I can show it to you. The thing to note is, in SGP, if you've used it, you notice it fits a line to both sides of the curve. Well, this fellow will fit that curve with a parabola or a hyperbolic curve. And it's pretty slick. I think SGP added that recently because I guess Voyager probably has done that, and Nina did it, so SGP added it.
Is that, Michael, is that something that's determined by the type of scope you're using?
No, it's just when you measure. So what a V curve is, if you haven't ever done it, is what it does is it moves your telescope slightly out of focus, and then your star becomes either a donut or just a little disc. And then it moves the focuser through focus and then to the other side. And what you'll see is obviously the disc shrinks down to hopefully a very small point and then gets large again. The V curve is just the size of that disc, is a function of the focuser position. And very far away from focus, it kind of, it's the wings of either a parabola or hyperbola. And so it becomes very linear. So traditionally, things like Focus Max would fit a line to each side, and where those two lines crossed, it took to be the focus position. What people are doing nowadays is you fit the entire curve, because due to seeing and other things, as you get close, if you were in outer space with the HST, that would go down to a very infinitesimal size almost. But because of the atmosphere, you can't focus the star down to, a very tiny size. So it kind of flattens out at the bottom. So it's more of a parabola. So no, for any scope, it ought to work. I used it with the C8, and it was fitting the points almost exactly. It was pretty awesome.
Parabolic mode, you mean, or?
I might have used hyperbolic. I don't remember.
Okay. Okay, cool.
I could load. When we do a night out, I'll have all those settings there. But so this is kind of equipment for imaging. You can tell it to save as fits. You can save it as this bizarro format that PixInsight's pushing, but fits is the most easy to move around. And it has a header, so all the interesting stuff about your observation is stored. I would not save it as TIFF. That would be
The
my
only
last
place
one.
I've ever seen support XISF besides PI.
I thought about writing a Python module to support it, but there's really no reason. So down here, now this in SGP, you can set how it writes out the files. And it's a little, it's a little WordPerfect 1.0 looking or something. But basically, here's your legend. So what this is saying is create a directory called image type, which if you look down here, image type is it's either going to be light, flat, dark, bias, or snapshot. And here's the example. So if you're taking a light frame, it would save it in a directory called light. Then it would make a file name, which is the date. Then your filter, the temperature, the exposure time, and then the frame number. But you can put all these other, like I always put the, let's say you wanted to add the gain, you would do, what's it, $, gain, $, underscore, and I usually
What's the
gain.
backslash in there doing in there?
The underscore? Oh, he used dashes, didn't he?
No,
The backslash means create a
backslash
directory.
after an image type there.
That makes a directory.
Ah, okay.
So I usually invert these. I usually have date out front, right? So, I would take this
Okay,
part.
so that's it makes a directory instead of a file name part.
Yeah, because I like everything organized by date. So I would do that. So then it would, I would actually just do date, right? Sorry, I'm getting sidetracked, but it does date, then light, and then I would always, actually I would have target in the name, right?
Yeah, me too.
So you would do $, target, dash. Which, did I do it wrong?
Target
Oh, is it
name.
object? What do they call it? Target
Target
name.
name.
Okay, so you get the idea. Target name. Okay, I'm not wasting time with that. But anyway, you can specify what you want here. Although actually, yeah. So then over here you can set up Meridian Flip, which means, for example, if you set this to 5, then what would happen is it would track 5 minutes past the meridian, and then it would flip your scope. And then this recenter on flip means it does a plate solve before it flips, and then it uses that position after the flip to reacquire where you were. And then you can tell it to do, now like with an SCT, you might want to do an autofocus after you flip because something might have moved. So you can turn that on here. Down here, you can tell it where to store. So this directory over here, Steve, is relative to this position on your disk.
Okay.
So that's where it's going to put everything. I don't know what the sequence template does. I haven't investigated that yet. So you can tell it to park when it's all done and turn the camera cooler off. And if you have a cover, it'll close it. So, you can kind of do a little bit of automated stuff here at the end. And then plate solving. So you can choose which plate solver you want to use, which blind solver you want to use. Then tell it, use 7 seconds, bend 2 by 2, always use, you could tell it, like always use the L filter. So if you're imaging in H alpha, you might want to have it switch to L just because you get more stars for plate solving. It does support gain. So you can set the gain. I don't think I showed that on the sequence, but I think here's somewhere. Well, okay, if I had a camera if this camera supported gain, I think there's a column here for gain when you set up your sequence. And then you can set the tolerance. I want to point with one arc minute, and you can do one attempt if it fails. Down here, you tell it like where ASTAP is installed or where plate solve 2 is installed. So that's it. That's the whole program. But for most of what we're doing, where you're setting up and imaging, it covers most of the bases, unless you're getting into some advanced scheduling where you're hitting multiple targets a night or something. But
So it'll run multiple sequences. It just doesn't have a nice way of.
right. And in
doing
theory, I think it'll do multiple targets. So let's say later in the night, what's something that comes up real late? Like M13 maybe? I don't know.
Yeah.
Let's say it
Good
does.
one.
I type it wrong. Oh, I think I have stuck with galaxies. That's a galaxy later at night. Yeah, M50. Well, let's just do M51. All right. So we're going to do that. We're going to frame it, and then I'll add it to the sequence target. What I think it'll do is it'll go through the first sequence and then do the second one. Now, you have no guarantees by the time it gets to the second one, it's still up. Well, let's just throw it in. All right. So you can see here I have M106, and then later question mark, whatever. Okay. So you can see I have 2 targets, and this one says it's going to finish at, wow, why is it 4 hours? Oh, because I threw all these things. Okay. So it's going to finish like almost at 8 p.m. And this one, it's going to, well, see, yeah, I don't know how, I haven't, right. So for this target, it would start at whatever time that, it would start when the other one ended and then run, let's give it some actual data. Let's say an hour. So it would run between 8 and 9. So let's say you image M106 and then your next target wasn't up to for like 2 hours. You could set a 7,200 second delay here. It would wait. Now, for some reason, it doesn't reflect the delay in this number, which is annoying. But, you know, so you could do multiple targets. You just have to kind of do manual.
Yeah.
So, I mean, they're working on it. So the thing about that's weird about Nina is there is no real forums. They use something called Discord, which if you remember IRC from the old days, Internet Relay Chat, kind of looks like that, except apparently they sniff a lot of info off your computer. So I use the web client in anonymous mode, but they're really responsive. If you get on there when people are on there and you're having a problem at that moment, they'll go, oh, we'll try this. So it's an interesting group. You know, again, it's an open source project, so they're not getting paid, so you can't really scream at them if it doesn't work. But if you're nice, they'll probably implement something you ask for. But I've been on there a few times, and yeah, it's pretty good. And if the developers aren't there, there's probably other users on there that can answer your questions. So it's getting quite a following, I think. You know, it's kind of eaten under SGP a bit. APT is really nice. I used it for a few projects, but it doesn't have autofocus as far as I can tell, which kind of is a drag if you're used to it. So this is version 1.10 nightly 76. You see that up here top. So they're working towards a stable release of 1.10. When they do that, they're going to start the next one. I don't know, 1.11, I guess. And in that, they're supposed to really work on sequencing. But they're trying to get this stuff stabilized first. That was probably more than 5 minutes. If there are any other questions, I'm happy to answer them. But,
hey, Michael, I have a quick question.
Yeah.
You've never elaborated on your particular setup at your house. Do you use something like TeamViewer? I know you don't stay outside. How do you communicate with your stuff outside?
Yeah, so I use something called VNC. It's been around forever. It's kind of like Windows Remote Desktop.
Mm-hmm.
But I like VNC because they ported that client to everything. You know, I have a client on my phone. So, you know, you can keep up with the phone. You can use it on your PC.
Okay.
Was that VNC or BNC?
Yeah, I'll show you. Let's see. I have a few of them. Let's see that one. So hopefully this won't embarrass me. Let's see here.
Now, TeamViewer is free for people who are
so
not using.
This is like a Linux server in my one of my other offices. So I'm running this on this computer, but essentially, you know, I'm looking at another computer using it.
Mm-hmm.
So
I don't see anything other than Nina right now.
Oh, right.
Yeah, I tried the Google remote desktop that I think Roland, you suggested, and that seemed to work pretty well too.
Do you see it now?
Yep.
Yes.
Yeah, so this is a Linux machine somewhere else in the house and so I basically get this kind of view for it. Yeah, TeamViewer, you know, they got pretty uppity about sniffing if you're using it commercially or not, which implied to me that they're watching what you do on the computer since they can tell if you they think they're using it for commercial use. So
Oh,
they never really interested in me a whole lot. Yeah, the Google one is interesting if you're okay with Google watching everything you're doing, I guess. You know, as far as I know, these VNC clients are open source, so everyone in theory could review the code, and if someone's doing mining Bitcoins or something, we'd find out about it. But I've just always used it, and it's kind of OS agnostic, so it works with Android, iOS, anything. There's another one that I saw a lot of people in the astrophysics mount list actually getting pissed off because of TeamViewer. So they found another one. It's, oh God, what's it called? I'd have to look it up. But apparently it's ex-TeamViewer employees who kind of got sick of the whole thing and started their own company. And it seems to be a little more generous about pre-use.
So AnyDesk?
No, it was something like no machine something. I don't remember. AnyDesk was another one that people used and seemed to be happy with. But yeah, I've always used VNC for God since 1994. So it's just kind of my fallback. But any of them will work, and I recommend it because, well, for me, my scope's sitting on a deck. If I look at that deck, I'm got 3 arc minute of shift. So I can't go out there and like set up the thing. I have to set it up, come inside and do it because it's on a deck, you know. But also, you know, when it's 3 a.m. and 10 degrees, I don't have to go out there and figure out what's going on. So it's worth doing. I mean, I know a lot of people set up in their driveway in their front yard, so that's not really a luxury, I get. But even then, you know, it's kind of nice to maybe you can sit nearby and watch what's going on.
I set up a motion camera outside, so if anyone gets close to it, it pings me inside. So
yeah, me too, Mike.
Yeah, well, if you guys work on Roland, he might open up a hosting service someday. But
yeah, we you know, with the pandemic, the roll-off roof has been put kind of on hold because my builder is not leaving Ohio, so we have time to negotiate a larger building.
Oh, jeez.
Yeah, I thought about it, but I don't know. I like tinkering with the stuff, you know, and I wouldn't mind visiting Roland, but having to drive out there right now might put a crimp in my style. But I imagine someday that's going to be, if we're serious about this hobby, that'll be a reality. But all right, well, I appreciate everyone being patient. I enjoy talking about this stuff, and it's y'all been great. This has worked out better than I could have hoped. You know, it's a small group, and we can all share ideas. So it's
thank you.
Honestly,
thank you for the
anytime someone
presentation.
wants to do this, I would say let's just throw out the idea. You know, we can get Chris or Roland to host it. You know, we can do these things.
Worked great.
All
I
right.
enjoyed it. Thank you.